Hi, in this video, we will configure BGP for Address Family Identifier, VPN v4 Unicast and L3VPN EVPN. And then we will steer the path of VPNs over SRTE policies. We configure PR3 and PR4 as BGP-RR, that is route reflector. First, let us configure BGP on PE1, PE2, PR3 and PR4. Later, we will configure BGP on CE1 and CE2. Here CE1 and CE2 is running iOS XE. So we'll cover interop between iOS XE and iOS XR. Let us jump into the configurations itself. So right now I am on PE1, so we'll go on configure terminal and router BGP and AS number as 100. So I'll give BGP router ID as loopback IP, that is 1.1.1.1, and address family as VPN v4 Unicast. Now I will also configure address family as L3VPN EVPN. So I'll create a neighbor group for RR where our remote AS is again 100. So our updates source will be loopback interface and address family will be VPN v4 Unicast. Now another address family that we are going to advertise to RR is address family L3VPN EVPN. So our neighbor, that is RR, is PR3 and PR4 whose loopback IPs are 1.1.4 and 1.1.5. Let us configure neighbor for 1.1.1.4, that is PR3, and we'll use our neighbor group RR. Similarly, configure neighbor 1.1.1.5 and use neighbor group as RR. So with this, we'll commit our configurations. Now check the configurations. So what I will do, I will copy paste these configurations on the other routers, and then we will change the neighbor IPs and the router ID. With the configurations, and paste it on a notepad. So I will do these configurations on 1.1.1.8, that is P2, that is P2's loopback IP address. So let us copy these configurations and paste on P2. So commit the configurations. So commit the configurations. No configurations has been committed. And you can check it where show running config router BGP. Now let us go to PR3 and PR4. There we will configure PR3 as our RR. So to do that configurations, I will slightly change the configurations of PR3, that is RR1, and PR4, that is RR2. So PR3's loopback IP is 1.1.4 and our neighbors will become 1.1.1 and 1.1.8. So I'll change the neighbor group's name as RRC, that is these neighbors are our route reflector, and I will configure neighbor group as RRC. So under address family VPN v4 Unicast, I will configure route reflector client. So this particular configurations configure the router as the route reflector and the neighbor as its clients. So let us copy these configurations and paste it on PR3, that is RR1. So commit these configurations. Commit the configurations. Now check it with show running config router BGP. So configurations are committed successfully. Now I will do the configurations of route reflector on PR4 whose loopback IP is 1.1.5. So rest all configurations remain same. So copy these configurations and paste it on PR4. So commit the configurations. Once configurations are committed, just check show running config router BGP for verification. So configurations has been committed. Let us go to P1 and P2 and check the configurations. Check the neighbors, show BGP all summary. So you can see here there are two neighbors, that is 1.1.5 and 1.1.4, and another two neighbors for address family L3VPN EVPN. So I will just execute this command again just to check what is address family. So for address family VPN v4 Unicast, we have two neighbors, that is 1.1.4 and 1.1.5. For address family L3VPN EVPN, we have another two neighbors, that is 1.1.4 and 1.1.5. Remember, 1.1.4 and 1.1.5 are route reflectors. Let's check same configurations on P2. So show BGP all summary. You can see again on address family VPN v4 Unicast, we have two neighbors. Those are route reflectors, and for address family L3VPN EVPN, we have another two neighbors. So what we will do now next here is we'll go and configure BGP as PEC protocol. So before going for configurations, let us check our topology. Our topology remains same from the first video. Here we will configure PEC protocol as BGP. That is, we'll configure BGP between P1 and C1 as well as P2 and C2. Now this BGP neighborship will be on the VRF, and that neighborship will be on a different AS. That is, we have an eBGP session between PE and CE. So let us go to PE1 and start configurations for VPN and PEC protocol BGP. So I'll configure VRF with an name VPN1, and address family will be IPv4 Unicast. So I'll import RT, that is a route target, as 65,000 1:1, and I'll export route target as 65,000 1:1. So I'll configuring import and export both route RTS both 65,001. So now What I will do here is I will go and configure PEC interface. Our PEC interface should be gig 0/0/2. So you can see here gigs on gig 0/0/2. I will go and configure VPN with an IP address. So VRF will be VPN1, and I will give shutdown, and IP4 address I will configure in 192 range, 192.169.1.2, and that is /24 IP. So I will commit the configurations. Now I will configure BGP as PEC protocol. Before configuring, we have to create a route policy. So I'll create a route policy called pass, because for eBGP we should have a route policy. That is how the iOS XR works. Without a route policy, you cannot exchange any routes in the eBGP session. So I will pass all the routes, and this is end of our policy. I will commit the configurations. Then I will go to router BGP. Our AS is 100 on PE1. So I will give address family IPv4 Unicast. So because we are exchanging the exchanging IPv4 routes between PE and the CE. So configure router VRF VPN1. Give me a second. We have VPN1, and I'll configure RDS 101 and address family as IPv4 Unicast. So I'll also configure AS path loopback checkout disable. So I will configure redistribute connected. Then I will configure neighbor. So neighbor is 192.169.1.1, and remote AS will be any AS which is having an private remote ID, that is 65,001. So address family will be IPv4 Unicast. I will configure route policy. Our route policy's name is pass. We have to give in and as well as out. So I'll commit this configuration. So let us check the configurations that we have configured. Show running configure VRF VPN1. Show running configure interface gigabit ethernet 002, and then show running configure router BGP. So on the router BGP we have configured address family IPv4 Unicast, and then on VRF VPN1 we have configured the neighbors with route policy. So what I will do is I will just copy these configurations, copy all these configurations and replicate it on PE2. just remove these configurations which we already configured in our previous step on PE2, and the neighbor will be 2.1, so I'll configure IP as 2.2. So let us copy these configurations and paste it on PE2. So commit the configurations. So the configurations got failed. So we have missed, I think, route policy. So let us go and configure route policy. Now commit the configurations. So configurations are successful. So our PEC protocol has been configured on PE1 as well as PE2. Now what I will do is I will go on CE1 and C2 and start doing the configurations for CE1 as well as CE2. So CE1's gig 0/2 is connected to gig 002 of PE1. So first let us configure the IP address on gigabit Ethernet 2. Just configure no shit. I'll give IP address. So I'll configure an interface loopback 0. So this for forming the neighborship. I'm configuring interface loopback such that I can advertise the network of loopback IP in the BGP, and then we can do a traceroute or ping. Okay. So I'll configure 2.2.2.1 and it is /32 IP. So now configure a router BGP. And neighbor will be 192.169.1.2 and remote AS is 100. Address family will be IPv4 and neighbor 192.169.1.2 we will activate it. So we'll advertise the network, that is 2.2.2.1, that is loopback IP, and mask as 255.255.255.255, that is /32 IP. We'll configure neighbor 192.169.2 where we'll allow AS in because we are configuring 65,000 as our eBGP neighbor on PE2 also. That means on CE2 again we are configuring router BGP with 65,001. That is our AS number. So let us end these configurations, and I'm writing these configurations. Let us check the configuration on interface gigabit Ethernet 2. And then we'll check configurations on BGP. And we have also configured loopback address. So replicate same kind of configurations on CE2 also. Then we will check the end-to-end connectivity. Okay, so copy these configurations. This is 2.1 2.2. We'll configure a loopback IP as 2.2.2.2. So let us go and configure loopback IP. I hope these configurations are enough. So copy these configurations and paste it on CE2. I hope interface gigabit 2. I will give no shit. And now we will go to CE1 and check the neighbors. Show IP BGP neighbors. Show IP BGP summary. So you can see here we have 192.169.1.2. There is PE1 as our neighbor, right? And we have received two prefixes. Okay. So similarly, I will go on C2 and check show IP BGP summary. So we have 192.169.2.2 is a neighbor of C2, that is C2's neighbor is P2 IP, and we have received three prefixes. So let us go quickly and check the neighbors. What all the routes that we have received? We have received 2.2.1, that is sorry, what we have configured. Okay, we have received 192.169.2.0. I think we have yet to receive 2.2.2.2. Yeah, we have received 2.2.2. That is the loopback IP of CE2, and 2.2.2.1 is the loopback IP of CE1. You can see next hop as 0000. Okay. Now let us do a traceroute to CE1's loopback IP. Traceroute 2.2.2.2 and wait for the results. Okay, when we did a trace route, you can see here there is a label stack 16,008 and 24,007. The outermost label, that is topmost label, is 16,008. That is the prefix SID of PE2. Okay, and 24,007 should be an label which has been generated for VPN v4 Unicast. So let us go and check on PE1. So show MPLS forwarding. So you can see here on when we did an MPLS forwarding, we have 24,008 that has been advertised to the PE2. Okay, so if we check show BGP VPN v4 Unicast labels, you can see here for 2.2.2.2/32 the label was 24,007 that has been received from the neighbor. This is a received label, right? 24,007 that became an the bottom label. So the stack is having the 16,008 on the top and 24,007 on the bottom. That is an VPN v4 label. that has been advertised by PE2. Similarly, let us go to PE2 and check show BGP L2 VPN, sorry, show BGP VPN v4 Unicast label. So you can see here this particular router has received 24,009 as a label for 2.2.2.1, that is C2's loopback IP, right? Let us go to C2 and trace route for 2.2.2.1. So the topmost label will be 16,001 and the bottom label will be 24,009, because that is what P1 has advertised as P1 has advertised to P2. Okay. So trace route to 2.2.2.2. Sorry, I think 2.2.2.2 is the loopback IP of C2. So that is my mistake. So trace route to 2.2.2.1. So you can see here the topmost label is 16,001, that is P1's prefix SID, and 24,009 is the label that has been advertised by P1 to P2 for VPN v4 and for prefix to 2.2.2.1. So this is the end of our video. Thank you for watching this video.